So welcome to this session about showing the nearest React UI to basically to Christian and to Michael currently, but it might be also interesting to you who are watching. So I'm Sebastian Kurfürst and I will be your guide basically through the tour. Okay, right. So what is our what are we starting with? So we are currently basically starting at we have a blank Neos 3.0 demo installation, and then we installed the Neos React UI package in there, which is Neos UI. And when you follow the instructions in the README, then you basically have you get everything set up, and you should be ready to develop. And that's the state which you should use. If you use in a PHP storm or anything like that, there's one important trick, which is in editor file types, ensure that you have node modules down here and ignore files and folders, because otherwise your PHP storm or IntelliJ will crash because of too many file and dependencies and parsing all of that. So that's just an important trick. Took me a while to figure that out, actually. Okay, so if we go to the UI, let's just go there. And so you can go to the new UI by going to Neos exclamation mark, and then you'll enter the new UI basically, and you can edit content and all these things. So you should probably know many of these controls, or you've seen them already. So now it's really about what is going on like behind the scenes. So I'll just, if that's fine for you, Christian and Michael, I'll just walk you quickly through the UI, the file structure in the Neos UI package.
Sure.
So basically everything is in packages, and we use a system called Learner, which is a system for managing dependencies across packages, because we are essentially, the Neos project is so big that we don't just have a single NPM project, but many of them. And that's the ones you see here on the top level. The main project is Neos UI, so that's where where everything happens regarding the bootstrapping process and all of that. And then we have lots of other packages will come along across as soon as I show you around basically. So the application is a pretty standard React and Redux application. So that means we have a single store. We use Redux. We use Redux Saga for longer running actions, and we use the standard or the pretty standard split separation between containers and components. And that's probably the first important thing. So in components, these are in React UI components, these are all standard UI components from the Neos UI, like buttons, checkboxes, dialogues, all these kind of things. Everything which does not have a dependency on the Redux store, essentially. So everything which can be rendered standalone. So if you take a simple thing like an icon button, for instance, it's really having just a few properties. It can be rendered, and that's basically it. And the actual, most part, as said, happen in the Neos UI package. And the reason why we split that up into these many packages is first for code organization internally, but then also for reuse, because some of these packages will be published to the outside at some point to allow for extensibility, so that people can program against Neos UI essentially and write their own components and replace things. Right, so I'll first probably, I'm not sure where I should start. Probably I just start you walking through what happens if I click expand and collapse here. Just a really simple example, probably.
Why not, yeah.
If that's fine, if that's too low level for you, that's also fine, then you let me just know. But I'll try to cover many things as we come of that. So basically, in the index.js of Neos UI, we at some point render the root. So that's rendering the whole UI, basically. And the root then renders, here you see it renders modals, flash messages, the full screen part, the primary toolbar, blah, 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 until we are at the left sidebar, the content canvas, and the right sidebar. And the right sidebar, again, has a toggle button and then the sidebar component in there. So that's really So you see we have a sidebar, and the sidebar contains the toggle and the inspector itself. And actually, that's the, I'm just thinking, exactly, I think that's the one which I toggle as soon as I click here. So what you see, that's a class which extends from pure component. That's what we always use in React. And then the render method is triggered on every state change, essentially. There's some magic in this connect annotation up here, which is we are using a centralized store in the system. And the connect annotation connects the component to the store in both directions. I'll show you that in a bit. But just to visualize the store, it's easiest to have this Redux developer tool in here. And what you see is always when I toggle, hopefully, yeah, you see there's a toggle action which is called dispatch to the store. And then you can see, okay, this action will result in a state change. So which means is hidden will change from false to true, or the other way around. When I again toggle it, we see again a new toggle action, and then it toggles back. Just a few words about the state. The state is structured as a big tree of objects. The two most important parts are CR and UI. So CR is everything which is like the core data, the content repository of the system. So it contains all the nodes the system knows by context path. It knows what is currently focused. It knows what workspaces exist in the system or for the user currently visible. That's the one part. And then inside UI, we basically have UI state matching to different component parts. So there you see there's right sidebar hidden or not. That's what we just toggled. We have info about the page tree, info about the draw component, info about if the left sidebar is hidden or not. So that part, I think it's this one here. So all kind of different, or that was the draw, all kind of different UI controls, basically. So what happens when I click, so in the icon button on click, I execute this toggle sidebar method here. And this is a so-called, this is basically this second part of this connect method. And what you do here is you dispatch an action to the store. So an action is basically just a very simple, it's basically like a command and event sourcing. It's just a very simple object triggering a state change. Pretty standard to React. Is that understandable or clear or not? Or I don't see you, so I don't see your faces, so you need to keep this.
Yeah, it's clear.
It's in general, it's clear, but I mean, how is the syntax to be interpreted?
Okay, so add connect is a so-called decorator. So that's basically a function which is applied on the full right sidebar method, or on the full body of the right sidebar, and it extends basically the right sidebar component. And the first parameter of connect is everything is basically the connection direction from the state to your component. So it's basically reading from the state and putting data to the component. And the second part is the other way around, which is a function. So that's always a function where you say which action should be triggered when you press the toggle button.
All right. Yep, that makes sense.
And so actions UI right sidebar, that now gives us, if I open that up, that is not implemented in the main Neos UI package, but it's implemented in the Neos UI Redux store package. So that's actually where the state itself is handled. So you see in UI right sidebar, you see the default structure is exactly like the structure of the path. Then we have an index.js file. And there, this toggle method, this is the toggle action. This is actually the function which is being created. Okay?
Yep, that makes sense.
And then the action is dispatched to the store, and in the end, the reducer will be called with these different, or with this action. So that means this method will be called. And we are programming in an extremely, or in a quite functional style. So basically, so the basic idea, I just write it really verbosely now, just to make it clear what happens. So basically, so we have a higher order function. The first one is just empty. It could, the action can contain parameters, which our action doesn't currently, but it could contain parameters. That the first parameter, the first method essentially. The second, then it gets the state, and as a return value, it has to return the new state. And then we can use these helper functions like toggle, which switch the state, for instance.
Okay. Okay.
And important, the state we use is completely immutable. So we use a library called Immutable.js for completely immutable data structure, meaning always when you change the state, you will basically copy the state completely and get a new version back. So when I change is hidden, then this means is hidden changes. It also means UI right sidebar changes. It also means UI changes. It also means the top level object changes, right? Because basically everything up to that point is modified. And and Immutable.js ensures that this is basically fast and performant in a clever way. And this gets important or this is an important performance optimization. It sounds otherwise first because you say, okay, you always copy things around, but actually it's pretty clever internally, and it enables some really, so by ensuring the state is immutable and cannot be changed, enables some really important performance optimizations, which we are using.
Obviously, yeah, that makes sense.
Yeah, and then there's one other thing you need to know, which means these everything which is from Plow.js, which is a really nice functional JavaScript library from Wilhelm of the NEOS team. Basically, these functions are curried, which means that you can either call them like this with 2 arguments, or you can leave 1 argument away and call them, and then you get back a new function. And then you can add, if you call this function, you can call it with the remaining argument. So this is the same which I just wrote. And this looks now a little strange, but this enables us, this means I can also write stuff like this, because this is just a state function. This is a function just getting the state and returning the new state. So I can also just remove this and remove this indirection here. So it takes some time to get used to, but that's essentially all functionally equivalent what we do. And so the way I think always about it is like, okay, we have a, if toggle happens, then please toggle the value at this path, and you don't need to know exactly where the state is. In this, it's a very functional style of programming, basically.
Yeah, cool.
Okay, so that means the reducer actually changes the state. And this is also what we see in the Redux inspector. And then what then happens is basically always the state changes. A full re-render of the full UI is triggered, at least conceptually. React does some quite clever stuff to optimize that internally and to ensure that not everything is rendered, but like conceptually, you can always think about, okay, the full UI is refreshed, and that's it. And what React then does is basically it re-renders everything which has these connect annotations on it, and now this is hidden property is fetched from the store using the selectors. UI right sidebar is hidden. Okay. A selector is basically, or not basically, a selector is just a function which takes the state as input. So I'll just write it again. So that means selector is a function which takes state as input and returns some part of the state. Okay, so it's a function taking state as input, and that's it. Mm-hmm. And so that means I can actually use something like this get method as a function which can access state, because that's again from the Cloud.js library. I could also write it like this. I could say state, like very explicitly. I could do it like this. Yep. I could again do it like this, and this is now the same as removing the argument again. So that's what you get from it. And so that means this thing is re-rendered completely. this is evaluated, this is hidden, and is full screen. And if the data changed actually, and these parameters, then the component will be re-rendered. Then this render method will be re-evaluated. So that means this code is re-executed when things change, and then it leads to the, I think, yeah, exactly. Here we have the toggle icon actually switches from left to right, and then this thing is re-rendered, and that's it. Okay, so that's like every change we do will always go to the Redux store. There the modifications will apply, and then we get back to our components. And there the component is re-rendered.
All right.
And what React does also internally is there's still some like second level of optimization, because React will basically not re-render everything just to the DOM, because the DOM is slow, but it will re-render to some in-memory representation of the DOM, and then do what they call the virtual DOM diff. So they check the differences between the real DOM and the modifications they need to do, and that's what they apply. But that's nothing, that's more like an implementation detail to further speed things up. That's basically nothing you need to keep in mind. It's just for
yeah, of course. Yep.
Okay. So that's basically
if you go back to that component, I mean, I understand the selectors thing, but why do we access the state directly in the is full screen?
Actually, that is still a leftover. It would be much more nice to have a selector in here.
Okay. Yeah.
So we are basically trying. We figured a lot of things out, or tried a lot of things out with different coding conventions. And what we ended up with is that we have the actions, the reducers, and the selectors for a certain state part in the same file. Because essentially you read it from top to bottom. You say, okay, what can you do with the state? So what are the events, the commands coming in, the actions? Then how is the state modified when such an action comes in? And then how can you access the state? It's really, reading it from start to finish in the file. So that's the convention we ended up with. And so basically these kind of calls should all go away, basically, and we should all have them using selectors something. That's just not done in that specific case yet.
Okay.
So, and then there's one specific part which you still need to know, which is, I think that's our pizza. 1 second. Okay, so which is we still have so that's easy for simple properties like changing toggles or these kind of things. But for more complex calculations, usually the state you have in your model and the thing you have in your UI, or what you need in your UI, don't match exactly. You need to change. You need to transform your state into something more usable for the user interface actually, and this is done in so-called selectors. Also in so-called selectors. And we use, I'll just search for a nice example. All right. For instance, that one is really simple. And there we use a selector library, which is called reselect. And what this basically does is something like computed properties in Ember. So you basically say, okay, this is a property depending on this input. It could be other selectors. There's again another selector, and then you have one function to calculate the output depending on the input. And the nice thing about these selectors are that they are memoized, which means that they are only calculated once, and only when the input changes they are recalculated again. So that's also important for performance optimizations. So basically, you can imagine. Something in the model changes, and then like a tree of selectors might recompute if they changed, and this way you can transform your data into the format which you actually need for your user interface to make sense. Okay.
Okay.
So far. Okay. So let me think. What else is important? Okay, so now I would so far I think it is actually a pretty standard like React application, which you could also see when you follow like normal React tutorials. The only difference is like in which packages you will find the things, so that you actually work across multiple packages. But that's pretty much the only difference compared to as you do a normal React and Redux tutorial. Now I would actually like to introduce the extensibility concept, I think, because that's something really special to NEOS. And that's, or do we have questions so far? Because otherwise then.
No.
Christian?
No, not really, not really. I mean, there are a few things that I might just find in some default React tutorials.
Yeah, I mean, as I said, if you have specific questions like why is it this and that way, then just ask. You can also, then it takes some time to get used to it, and it's a lot of ES6 syntax as well. So and I personally also needed some time to get used to it. At first, it was like, oh, what is that actually? What is these kind of syntax? And but now it's getting better and better all the time. And actually, the nice thing is it's just very standardized. Right. So the manifests. So we thought about a way to extend NEOS and to extend the NEOS UI in a standardized way. And so, for instance, ways we thought about extending where we wanted to extend the editors here on the right side, so that you can add new editors. We had the idea that you need to add new, I don't know, styling options up here, for instance, to add new drop-downs, like what stylings you have available here. We have so that's like the basic ideas we had. And initially, we have had like one specific extension mechanism in every part. That was like, so we had one specific one for editors, one for up here, and so on. But so far, we all unified it towards what we called a global registry. And a registry is just a big lookup table, essentially. It gets filled on initialization of the application, and then it is completely immutable throughout the whole rest of the application. So it will not change after it has been initialized. And it is available globally in the full application, so you can get there everywhere. And the only part where you can actually write to the registry is what we call a manifest. So a manifest is something like a configuration or special place for configuration. So the only place where you can actually write to registries. And just to show you for instance, the registry or the manifest of the NEOS UI package, what is done here, we have the global registry, and we add a registry for editing and preview modes. We add a registry for inspector, and in inspector we add another registry for editors. And then we also currently we try to document the registries inline, which means we try to explain what is in the registries, more specifically, more like a reference, basically. That's all just text so that you have a chance to understand what's going on here. That's like the idea. We have save hooks in the inspector, what happens when you press apply we need to upload a new image. We have validators, for instance, and all kind of things. And that means other packages, like for instance, we have a special package for let me see, NEOS UI editors. What they do in the manifest is they basically just say, I'll take the inspector editors registry from the global registry, and then I add some components, so the text field editor, the text area editor, the Boolean editor, and so on and so on. So that's like that's the basic and most fundamental extension mechanism of NEOS in the UI part. And it's built in a way, it's not yet exposed, but it's built in a way that you can also do that in custom packages, so that you will not need to recompile the NEOS UI to add new functionality. You can always basically load new JavaScript files which add to the registry, and by this you get new functionality into the NEOS UI. That's the basic principle. Right. Questions so far?
Nope.
Nope.
Okay. Let me just think. What did I miss? That's the most specific question. So let's just show. Yeah, for instance, I can just show how the inspectors work here on the right. So what is done here? So we have in right sidebar inspector, we have a class again. Which which has again a connection to the state. This is this add connect annotation, right? So it contains information about focus node, transient values of the current node, and I'm not sure. That's actually duplicate. You see, focus node and node is the same selector, so that doesn't make sense. One would be enough. That should be changed. And then you have like what happens on apply button press, what happens on discard button press, and then commit button press. So when I change things here, that is what's happening. And then we have this special add neos annotation here. And what this does actually is it allows you to fetch things from the global registry. So that's actually how you can access the registry at a component. You get it injected. So you can say, I'm interested in the node types registry, and then you get the node types registry as props injected in the full component.
Okay, cool. Yeah.
And just to show you, so basically what we do in here is we render the tabs. In the tabs are the tab panels. I think in the tab panel somewhere are the property groups, and the property groups are the toggles. So that are like the individual boxes in here, like the toggles we have here. In the toggleable panel, contents is the inspector editor envelope, finally. And that's actually the component which calls a certain, or which resolves which editor to use. So that means this is actually, there's one more level of indirection. We have the editor envelope in there. And the editor envelope will finally, open it. It has connections to the global registry, right? Because it needs to know about all the editors available in the system. And what it in the core actually does, it will fetch the editor definition from the registry. And if there is a component available, then it will just render this single component. Basically, that's it. So that's like the dynamic dispatching of React. And the nice thing is, because you reference a React component always, that's just this JSX syntax just references a local variable you have available here. So that means if you see that, editor component is just a variable. So that means that's exactly this variable defined here. Or for instance, for I18N or for label, that's a variable which is imported in the header. So, and this way you can essentially, you need to always import these components together, and there is no magic in wiring. It's really just imported, or it's a local variable, so you can directly jump to it. And that's quite understandable as you get used to. And as said, it's again the same thing. If things change, it's again the big global cycle to the registry, the big global cycle to the state changes, and then some parts of the UI are re-rendered. That's just this thing over and over again, and that actually makes the whole UI very predictable, because if things break, then you can very easily check individual errors. So for instance, you see this page tree toggling. I can also skip certain actions and say, okay, I'll try to skip one action and see what UI behavior I want to, I don't know, I'm not sure what I'm. So I can very fine-grainedly say, okay, what should actually happen, and replay my current actions if I want them. So for instance, trigger something like, okay, how does this loading indicator look like? That's just, I mean, it's pretty standard React actually, but that was actually what like blew me, or what convinced me so extremely in the beginning, was because it feels very predictable. It feels almost like a synchronous application, although it's very asynchronous. You have for instance, we are doing a lot of Ember, or we have done a lot of Ember work at work, and also in the Neos project. And there you always had the problem. It worked in like 90% of the cases, and the last 10% you had just weird lost updates. Things didn't work out for some reason, whatever. And that's not to blame the framework, but it's just the way, like the conceptual way Ember worked was just way more complex actually. And you always had to deal with these quirks of the framework, with these issues where things didn't really work out. And with React, it just was so much easier actually to it felt like synchronous server-side programming essentially, although it's asynchronous. Right. I think actually that's, I mean, what I could actually, I'll probably show just the most important parts of the UI. So Neos UI, as said, is the main package tying everything together. The second important part is Neos UI editors, because it contains all the standard editors we are currently available, which contains big editors like the image editor and simple editors like Boolean and datetime and text area. Then we have the Redux store, like which contains all the state structure of the store. And we have UI components, which contain very, very basic UI components like icons, buttons. So we don't use this. We normally don't use a predefined UI framework, but we rebuild the components from scratch because just we as a Neos framework see ourselves as the framework provider essentially. So we want to ensure that it fits together well, and yeah, that's it. Okay, so that's basically it. I would have just one more special thing to show regarding the iframe. So far, okay, or what, have I been too quick? Nope.
No, that's fine. I would have a couple of questions after you finished. So.
Okay. You can also put your questions now if you like. So you don't know.
I mean, okay. So maybe it would be interesting to see how information from the server side is transferred.
Okay.
Like, for example, the translation labels is probably a simple thing.
Very, very good question. So if you look at the page source of the outside UI, you basically see just a few script tags which import the website, and then you have a big block of JSON in the body here. Very, very lot of JSON. And this JSON is on the, so we generate this JSON which is configured in the settings. So we have actually here in this is the backend part. So here we have either expressions of the state structure as it is created for the UI. So that's basically, that controls how the JSON encoding to the UI works. As soon as this is done, so that's like the server side part, and the other part is in Neos UI source in the index.js. So really in the root of the application. What we do here is we fetch these translations. For instance, so we fetch it with system get translations, Internally, if I'll find it, it's in system index. So get translations. So what this does is really it's going for data JSON translations, taking the inner HTML and parsing it as JSON. So it's really, so there's something, so it's really putting out this part here and JSON parsing it. And then the translations, as an example, are registered in the registry as well. So so I've actually lied when I said that the only place where the manifest, or where the registry can be modified is in the manifest. The second place where it's allowed is in the bootstrap of the application itself. So that's something the core can do. For instance, it registers the node types, it registers the localization objects also in the registry, or it registers in the registry what edit and preview modes are available.
All right.
Yes, and starting from that point, it's immutable again. So as soon as ready is dispatched to the system, then nothing is allowed to change anymore. Right. More questions?
Yep. And totally on a conceptual level, but I was looking into editors, and I was wondering, with the immutable components, how would I handle a AJAX request? Because I mean, for example, the select editor usually, or in the old UI, could do AJAX requests for options, and it can't right now. So I looked into implementing that and thought, how do I do it?
Yeah, well, actually, that's a good question. Actually, it can do it. So there's a pull request open currently, which is I can show you. It's a very basic reference editor. It's not really polished, but and it's not on the right places, but it's like the general idea is there. So we are using the fetch API, which is just basically a fancy AJAX call method.
Yep, okay.
So that's built into the browser. So it's like the new AJAX, basically, the new XML HTTP request. And what the reference editor still can do, and this one does, is it actually, I hope I find an example here, search notes. It can asynchronously do things. So so search notes is this fetch function. And in the, the select helper understands that it gets passed in not the options as a list, but the options as a function.
I see. Yep. Okay.
And this function is asynchronously executed, or this function can asynchronously execute to do an AJAX request to populate an input field, for instance. So that's also what's basically done here in this part of the code. So there's a component could have local state if you like to. So for instance, we have the drop down, for instance, that's a good example. Drop down. So the drop down is just a really basic thing which you can expand and collapse here, right? So I think that's a drop down actually. And if you check it, then this has local state by using, oops, where is it? View component, render. Oops. I'm just trying here this set state. So,
yeah.
So actually a component can have local state. So not everything should be put into the global into the global state, but just like the core state of the application, the thing which many things are interested in.
Okay.
It's totally fine. But in our case, for instance, we have complex logic. Like if this changes, then the apply button must be visible, and this is why we put the transient state into the state as well of the application as just as example. Right. So
yeah, right. Makes sense. But I mean, in that case, I would like put if I wanted to do that, put the AJAX response into a local state if I wanted to use
exactly.
and then put the actual selected value into.
Yes, exactly. I also thought first that was strange, but actually it felt quite natural now after a while. So yeah, I also stumbled at that point. Yep.
Okay, and then maybe last question for now. How do I deal with dependencies? Like, for example, I was looking at the code mirror thing that we have in the OTI, and there is a React code mirror thing. So I thought I could just use that probably.
Yes.
But where do I add it to the inspector editors thingy, right?
Yeah, exactly. You could add it to the dependencies of in this case Nears UI editors, right? Because you would actually wrap the component into one of ours, right? And there you could just add them. The thing is, you need to do. I think you need to do again, and you need to do here this Lerner bootstrap again, and you might need to do a clear beforehand. So actually, changing dependencies is a little nasty because it takes quite a while. So Lerner bootstrap downloads the internet, and that takes a while.
Yeah, I mean it doesn't need to happen quite often, but it's important to know how to do it.
Yeah, exactly. So what I usually do as soon as when I just want to develop something more quickly is that I just install it just really quickly using npm install first. This way it gets installed into the basically global node modules, what you don't see currently here. And it's still visible. It can still be used because node modules is also searching in parent directories if you look for something. And as soon as everything works, because I usually want to try out often, okay, which component will work on these kind of things, right? So really quickly. And so that's what I usually do. And when I found one component which works well, then I'll edit and then I clear everything and reinstall it. And that takes a while then. Yeah. Yes.
Yep, cool.
So, right. So one thing I want to show is the iframe and the way this works, because that's also still special. So we render the inner part of as iframe, so the body part, and the only thing which is the same in the iframe is we have some most parts of the CSS basically are also shared, so that the controls are in here. So and what we I'll just. This middle part we call the content canvas. So basically the drawing board for the content actually. So that's the component is called content canvas. And I'd like to show and the content canvas essentially is just this. It's just a div. It has some class stuff, and then it has this frame component here. And this is a little magical because what this actually does is it renders an iframe with a certain source URL, and then additionally it renders everything which is in itself as React components. So that means this bar is a React component. I can show you. So it looks like a React component with strange styles, and I don't know, you know. It is actually rendered inside the iframe, but it is connected and controlled, and the JavaScript lives in the outside frame. So that means that makes the system a lot easier because the inline UI, for instance, has access to the store. So I don't know, Mark Active Node is focused. Can just let me just check the node toolbar, for instance. It can just checking for an example. It can just access the store basically. I'm just needing to find a good example. Add node probably has some connection to the store. I hope at least. Yeah, exactly. Here you see again, right? Add node has a connection which calls open add node model. So that if I click here, then I trigger this global state change. And so that's really an important trick we are actually using, and it took a while to get it right, and we tried a lot of things out, but that's just a really nice way because although we are using an iframe here, it feels like the component itself is inside the outer frame. And it also minimizes the amount of JavaScript we need to load inside the inner iframe. So that's really quite nice. And beforehand, we tried a lot of different things like loading React in here again and having it completely separate. Don't use React in here, and that's nasty, and you need to do it by hand. Basically, the only JavaScript which is inside the inner frame is inside the Niels UI CK editor bindings. So that's a really blank. So these are the files which are loaded in the guest frame. It's this guest frame API thing, and you see it's really just this 200 lines file or something, and that's it. So that's the only. So the CK editor initialization needs to happen inside the inner frame because that's what CK expects. But that's the only JavaScript we load into the inner frame. It's actually loading CK editor and this thing is short guest.js, but no React, not these components and all these things. This is all basically rendered from the parent into the child.
Yep. So it's basically static HTML in the frame, rendered from the outside, more or less.
What do you mean?
It's basically static HTML rendered into the frame from the outside.
Yes, static, but dynamic in the sense that
of course.
Again, you can basically hook into things, and if this is clicked, then you get control back in the outer frame and can do something with it. Yeah.
Yeah, obviously. But I mean, for the inner frame, it looks.
Yeah, for the inner frame, it looks like static HTML basically. Yes. And that, as I said, this enables quite nice way to work because as the end user, you don't need to know if you implement this button bar or this button bar, except because they are the same, and that's quite nice. Yeah. Right. I think that's actually that's it. What I think what is important. I mean, of course, yeah, it needs some practice, and there's some, and we are still cleaning things up. But yeah, we are actually starting on trying it out in real world projects now, and that's things we are still working on. Still other questions, comments? Did it somehow help to get an overview?
Yeah, of course.
Yeah,
I guess more questions will pop up when I start working with it. So
yeah, sure.
That's cool. I guess I mean, with my questions, I have a few starting points to do stuff.
Yeah.
I will get doing stuff, and then I probably have questions.
Cool. Yeah. Okay, cool. Then I'll just stop the Hangouts on air. So
Now I forgot one thing. If